Question 24. The graph shown below was obtained by plotting data collected during an experiment that was carried out to determine the internal resistance and EMF of a battery. Use the graph to find internal resistance and EMF. EMF and internal resistance of the battery are related by the expression V EMF equals I times capital R plus I times small r. Here V EMF is the EMF of the battery, I is the current through the circuit, capital R is the external resistance and small r is the internal resistance. I times capital R is also called the terminal PD, which we are going to represent as VT, V terminal. So we can rewrite this expression in terms of VT. We get V EMF equals VT plus I times R. Let's rearrange this to write in terms of VT. VT becomes equal to V EMF minus IR. So this is the expression used to plot the graph given here. And it has two variables, V EMF and R, as VT and I are given along the y and x axis respectively. So I'm going to take two different points on the graph to find two different equations and solve them simultaneously to get the values of V EMF and small r. So the first point I will take is this, where the terminal PD is 8.5 and current is around 0.24. We write it as VT is 8.5 equals V EMF will be just V EMF as it's a variable minus the current will be 0.24 R. Let this be equation 1. We can take the second point around here where terminal PD is 7 and current is 1 ampere. Write this as 7 equals V EMF minus 1.0 times R. This is my equation 2. Now to solve them simultaneously, I'm going to subtract them. So you subtract this expression and then we get the answer. 8.5 minus 7 will be 1.5 equals V EMF minus V EMF will be 0. Minus and minus here will become plus. So 1 minus 0.24 will be 0.76 R. So this becomes 1.5 equals 0.76 R. In order to calculate R, let's divide with 0.76. R becomes 1.5 over 0.76. That gives me 1.97 ohms. Now we can use this value of R in any one of the equation 1 or 2 to calculate V EMF. I'm going to use this in equation 2. So we get equation 2 as 7 equals V EMF minus 1.0. In place of R, I'm going to write 1.97. So move this to the other side. We get V EMF equals 7 plus 1.97. When you multiply these two together, you get 1.97. So V EMF will be equal to 8.97 volt. So this is how you can use simultaneous equation to find the value of V EMF and R. If you have difficulty solving simultaneous equation, you can directly use calculator for this. In your calculator, go to mode 5 and choose the first equation. The first equation is of the order a n x plus b n y equals cn. So a and b are the coefficient of the two variables and c is the constant. So in our expression here, Vt is the constant. Coefficient of V EMF you can take as A. Coefficient of R you can take as B. So we can make a table here for A, B and C. So from the first equation, coefficient of V EMF is 1. Coefficient of R is negative 0.24. Constant is 8.5. From the second one, again coefficient of V EMF is 1. For R minus 1 and constant 7. You can put these values in the calculator to find V EMF and R.